Hello, everyone. Welcome to this series of interviews with Cyen on cybersecurity. Today, we have a guest from the UK, Anthony Hodson, a senior technology strategist at Faptic Technologies. We will discuss about resilience and testing. So, how to think about high availability disaster recovery and testing without breaking your business in the process. Very important to understand. Hello, Anthony. Welcome.
Hi, Iva. Great to be here. Thanks for having me.
Anthony, let's start from the basics. What are the pillars of resilient digital transformation? Would these pillars also move with DORA obligations?
Yeah, very interesting. I mean, DORA sets out some very specific outcomes it wants, and those are very much based on what good practice has been carried out by leaders in the industry and trying to up everyone else's game to meet that. So there's nothing really new. There's no big new thing coming in here, but we have some good practices laid out. And for me, as an architect, many years architecting for availability, of course, that's what organizations want. You've got the availability of your infrastructure, so that might be your cloud provider. It might be you if you're running this yourself and you want to avoid those single points of failure, those SPOFs. And how quickly a failure can be restored is very important. And while we're thinking about that first failure, that primary failure, how what are the chances of a secondary failure happening in that time? Because you don't want that to take you out. So you've got to make sure you have that spare resource to do that. Some people call it redundancy. That's how we solve for the infrastructure failure. Then we have to think about the availability of the application. So if you're an independent software vendor, an ISV, or you're using a SaaS provider, or if you're providing all this yourself, how can you avoid an outage? How can you recover if the logical system fails? And Quorum is an example of this. So if there's a problem with one of three, that is excluded from the setup and things can continue in that degraded mode, but things continue to work. And you have to have a lot of thought from the application layer as to how to make this work. It can't just be done at the infrastructure layer, which we'll talk more about. And then we've got the recoverability of your application. So if everything fails, how do you make sure that that comes back in a working way? In that worst case scenario, what is the remedy for that? Because you can't make your infrastructure team solve an application availability problem in isolation. You've got to work together. And as we've come through the past sort of decade of DevOps and SRE, we'll talk more about SRE later, we have infrastructure as code. So everything is defined in code. It's created. There are lots of benefits of that, but also it's possible to destroy with code. So something like Terraform destroy can take out your application if there aren't specific safeguards in place. And there's all sorts of commands that can do that. As you get into Kubernetes, the same happens there. The next one is investing in automation. So we're seeking to avoid toil, which in SRE, service reliability engineering, is the things that you have to do, but don't necessarily really move things forward. So in your own home, that might be doing the washing up or sweeping the floors. How can we avoid that in technology? So that might be digging through logs to find a problem that reoccurs regularly. How do we make sure that that's not taking us away from more valuable work? And we can do this through investing in automation. Now, each one of these things that you seek to solve, there's a cost to solving that. There's a cost to maintaining that automation. But these pieces, they build up over time to make something more valuable for your organization, which is that time to do more valuable things. So as we think about this in our homes, maybe you've got a dishwasher, maybe you've solved some of that toil, maybe you've got a robot hoover and they scurry around. Maybe you have alerting systems in your IT estate which spot anomalies and bring those to you. All those things seek to remove toil. So that's a piece there. And then we've got the quality of the application. this can't be underestimated. If your application's quality isn't strong enough, if those software engineering principles haven't been done well enough, then you're going to have problems with the application crashing, right? Or not being extensible or taking too much to change. And there's an idea of technical debt. I'm sure we've all heard of that. But this is making things extensible, making sure that you can recover from issues such as, a dropped table and things like that. How does that work? That testing can all be done in a way that nothing changes. We've got ideas like service architectures where there are contracts between the consuming piece and the providing piece. And ultimately, we also want to make sure that the investments we make into these bits of software are reusable. So they're modular and they can be used in other parts. Maybe we use some open source pieces, which are bits of software that we don't manage, we don't write, but we can consume, and they're very reliable. So that's a huge piece, right? The quality of the application. Bit out of scope today, but if you don't have that right, nothing else is going to be reliable. And then there's this idea of active resilience exploration. So if we look at complex systems which have disasters, I think a good example of that is planes. The effort that has gone into making airplane travel very reliable is a great success, probably a great success of humanity to focus on a real problem. And there's a lot we can learn from that piece as well. So they have, some of these pieces that we've been talking about. There's usually 3 systems where one is required, and that quorum piece is put in place. And the outcome of this is that, air traffic is more reliable, more safe than train travel, even though they're up in the air. So there's a lot we can learn from that. Ultimately, the resilience piece comes through nicely illustrated by a Swiss cheese model, right, which is by a chap called James T. Reason. And you imagine you have all these slices of Swiss cheese, and it's only when the holes line up with each other that you get an issue. So the thicker the cheese or the smaller the holes, the better the chances of not having an issue are. And we can all sleep better with more reliable systems.
Probably in the summer of 2024, we actually experienced the biggest IT incident, which could actually be assigned very well to a change and lack of testing of this change, discussing the CrowdStrike. And it struck me also, you mentioned the airline as the safest mode to travel, but let's not forget in a supply chain, a complex digital supply chain, we are all on the same boat. And I mean boat, it's good in English language, choose this word very well, but in the sense that is not the most secure and sometimes a slow to progress, difficult and expensive to test. So we have seen how a failure in the testing of one single company, has thrown the whole world down on their holiday times, unfortunately, including, and now I read also Airbus CEO of Delta also blaming that security company for the loss of $500 million for this incident. So here we speak about serious disruption, not only in your company, but all your clients and potentially also the whole economy. But we also speak about legal liabilities, which are very difficult to justify or fix after an incident has occurred. You could not go back in time and test better. So this is kind of a difficult situation one should avoid. Speaking of liabilities, we also have DORA, the Digital Operation Resilience Act, which very strongly focus on resilience, right? That's the whole point, testing and improving resilience. What are specific the obligations in DORA in that respect?
Yeah, so there's a lot in DORA around resilience, as you would expect with the title, same as SRE, right? We're looking for an outcome there, and it's right up there in the terms. It's got some strong opinions in DORA and describes the regulatory standpoint, but it also helps with the technical standards, so the RTS, which talk more about the how. So we've got this lovely diagram that they furnished us with that breaks down different parts. So DORA Chapter 2, ICT Risk Management, then breaks into protection and prevention, and that's Article 9, and then Article 10 is detection, and Article 11 is around response and recovery. Most of the architecture happens in response and recovery, and also Article 12, backup and restoration. But there are aspects in the Article 9 that we want to touch on as well. So as we look at Article 9, we've got mostly security aspects. So we want to make sure things are encrypted at rest and in use. And we want to make sure that the system change processes are valid and secure. And all this very important security processes, procedures, and practices. However, if we look at the architecture side, which is sort of in my wheelhouse today, then we're looking at things like making sure that you don't lose your keys, which would be a bit of a ransomware own goal, how to make sure everything's encrypted there. As we move on to the aspects of prevention and protection, this is all about security, detection, and data loss. So the data loss piece has an architecture aspect as well, because you'd want to make sure that you can avoid the risk of your data being deleted, right? So ransomware can go in and delete your data, and that's an aspect of what happens in a ransomware. They'll go in and delete all your backups. So you have to think carefully about that. But as we look at Article 11, response and recovery, this is really where we're going to spend our time with high availability and disaster recovery, taking that. We have to meet a requirement to recover in 2 hours. And DORA says that it's got to be within a time that doesn't affect the market. Okay. And you could come down from 2 hours because you think it's more important, but 2 hours seems to be the backstop that everyone's using, unless there's a better reason for that. And to make that happen, we've got to work out what's inside and outside scope for this issue that we're trying to mitigate. There are some aspects that you're not going to be able to mitigate anyway. And it covers this in terms of what's going to be solved for. Now we can look down through some of the aspects that it has on this. There's a tough statement here. The maximum amount of data that may be lost from any IT service to the trading venue after an incident is close to zero. So to get to close to zero, and how close to zero is a relative term, we're probably going to make sure that our aspects, our execution venues are very close together, because without that, you're going to start to find that you've got issues with latency. Having more latency means that you have a bigger drift, I would term it, between what you've got on record and what was in practice. So there's a lot in there. If we jump into the backup and recovery requirements, where you put your backups, you need to make sure that these are physically and logically segregated. They're secure from unauthorized access, that you can recover all transactions, so that's zero data loss. But that's going to be at a point in time if you're doing backup, because backup is different to high availability. You need to make sure you can continue to operate, and that you need to complete the settlements that you're looking to do that day. Otherwise, you will affect the market. And this is full scale for your redundant ICT, and that you separate, if you have separate sites, you have to treat these as separate risks, and that the critical services, the services that must be present for you to meet your obligations to your markets, to your customers, without causing issues to the broader market, and even the country, because we're talking about some critical infrastructure here, are provided. And also, if you're an organization over sort of the minimum size, which is 2 million euros turnover and 10 employees, you also have to make sure that your ICT staff continue to have immediate access to configure these systems and get things up and running. So there's a lot to do. We can jump through various bits of the regulation to make this happen. But some of this is easier to do in a consultation than a webinar.
So ensuring the resilience, it very much also is based on the risk-based approach, right? You should identify what is necessary, so what is key important to you, but also what are the threats, what are the possible scenarios that could, let's say, impact these important processes or systems for your organization. In that sense, do you have an advice of what disaster scenarios to envisage to be best prepared?
Absolutely. So DORA's kindly explained some of this to us, and the RTS has helped us here. So there's lots of discussion that's needed ahead of this within your organization for things that you've seen before, things that you expect to happen that are not defined within DORA, but are still reasonably expected. So you need to have a bit of a think as a a thought leadership group in your team to find out which scenarios you want to mitigate. But DORA itself says you need to meet at least these aspects, and that's in Article 26, Section 2. I think it's on page 36 if you want to really dig into it. But those are external threats, which are cyber attack, gradual degradation of service. So that is to say things are working, but they're not working acceptably. And you need to be able to establish that is an unacceptable mode of operation and then move away from it. You need to be able to cater for a loss of premises, that's either full or partial. You need to cater for staff shortages. So if all your team are kept away from a conference or something and they can't get on, or telecoms issues, then you need to be able to cater for that. Climate and environment issues as well, thinking about the problems that can arise there. A big one, a significant one, probably one of the most realistic issues is the insider attack. I've seen this in my career where retailers have been taken out because someone has deleted their cloud estate. So that's a real risk as well. Political and social instability, which we're seeing in 2024 in the UK. We're seeing issues around that as well, not around data centers, but there are challenges there. Widespread power outages, of course, would be a problem. There needs to be an estimation of how long that's likely to last and whether you would be able to survive that. And then an important one, and we've seen this again in 2024 with the CrowdStrike outage, is failure of third-party ICT service providers. So going right back to what you were saying, Eva, I don't think people were considering these pieces that were tying the systems together. And that particular incident was about their testing, from what I've read. But this caused a problem for many, 8.5 million users of those systems because of this third-party ICT service provider causing an issue. So we need to think about all those and how to mitigate, and also if mitigation is even possible. Because Section 3 says, if it's not feasible on cost or risk, or it's an unforeseen circumstance, we can refer back to Section 1, which, to paraphrase, is to do something that makes it good enough and help you get a plan back to do that. We're going to want to think about how we get your apps back somewhere, and what's an acceptable restore time objective and what's an acceptable restore point objective to allow those critical services to resume. And you've got to think about this on the application level. So I was doing some work with air traffic control route planning with a partner to architect for that. And it became apparent that no matter what you do with these systems, there's going to be a point in a busy system, even if you can take a copy of the entire system at the same time, that there is some data on the wire that's yet to be consumed or will need to be reprocessed as we go through and restore. So there are principles in software engineering of idempotency, where if you ask a system to do the same thing twice, it will only do it once. And there's ways of architecting your services that allow you to deal with this sort of problem where either you have to discard things that already happened or you have to rerun things that haven't happened in the case of a restoration. And this is where the cross-functional team comes in, right? Of infrastructure, of the business, making sure comms are in place, and even third parties to do that testing.
Indeed. So what we discuss now is more about what to do, what to consider, and what are the possible threat scenarios. But let's also try to quantify, to give an idea of management when they make decisions. It's very easy after an incident, you think, oh, I should have done this and I would have saved this whole trouble. And then you can very much quantify how much it costed you, the incident. But resilience is not about avoiding or mitigating one individual incident. It's about not creating this incident. So how can we calculate or quantify the benefit of being prepared?
Absolutely. So the first question I'd have on the savings or the benefit of being prepared is whether an issue that you've already sort of listed as a possibility, whether should that happen, is it terminal for your organization? Because if it happens and it's terminal, then that's a pretty high priority, as long as it is a potential realistic issue, right? There are issues that we'll leave out of this, but is it reasonably likely that it would happen? And the second one is, can it be meaningfully mitigated? Is there a way to actually solve this problem? If not, maybe it's just a partial mitigation, right? How do we solve these particular pieces to improve the outcome, even if it can't be completely solved? But if it is a solvable problem, then the maths I use for this are fairly simple. So I did some computer science in my studies. There's an idea of big O notation. Now that uses algebra to calculate how efficient an algorithm is. And it uses a big estimate, a small estimate, and a medium estimate. And that's the bit of this I take away and use. So we want to look at what's the worst case, what's the best case, and what's somewhere in between, and calculate from that whether this is something that is going to save us money. But if we have to do it, right, we're going to have to do it. So I have a little spreadsheet. I've put a link to it on screen and show you sort of roughly how this works. But essentially, we've got the cost of the outage in terms of big, medium, and small. We've got the probability of it happening. We've got the benefits of fixing this as well to put into the mix, because when people feel safe, they do better work. So let's not discount that, but it's a relatively small piece. And we bring all these things together to work out a very rough model of what the savings might be. So you'll be able to see on screen here a rough look at what that looks like. Right. So this is a good starting point, and it will ultimately be for your organization to decide if these risks are worth mitigating. But DORA itself doesn't expect you to cripple your business in order to mitigate all the risks. So there is some reason there. You just need to be aware that, it's feasible that you would need to explain your decision making to a group of your technical peers should there be a problem. And I would encourage, for most of the things we discuss here, something called an architectural decision record, right? So the reasons behind the decisions you've made, those assumptions that you're using, because over time those will drift. And we want to make sure that we can go back to those principles and point out the thing that we used to make that decision, so that we can say, actually, that's changed.
And all of this, until now, we very much focus on our own organization. So, what I can do, what are the scenarios for my business in process? We mentioned the dependence on third party and supply chain, but the cloud as a technology infrastructure and also third party most of the times managed. How would the resilience look in that in the cloud?
Yeah, absolutely. So I see a lot of organizations have been to the cloud. They're looking to move back. Organizations are still looking to move to the cloud. If you go to different parts of the EU, cloud is used more or less. I've spent a lot of my career working in public cloud. So there are different responsibilities as we get into using a third party like a cloud provider in terms of DORA. Now, they're at a very large scale, so they will be all over this. As you look at smaller providers of services, they're going to have a harder time coming in line with DORA because they come in scope of this, and organizations in technology will be expecting those organizations themselves to make this work. But as we look at seamlessly doing DR to cloud or between clouds, we come across a limitation of latency. So there's a lot of effort that can go into ensuring what's over on site one becomes over on site two if you've got within 10 milliseconds. But if you've got over 10 milliseconds, then we have to start thinking about asynchronous recovery, and asynchronous always means that there's some form of data loss. So in the case of a catastrophic issue with your data, with your application, things like that, you need to consider what the blast radius of the solution is going to be. So are you expecting for your cloud provider to be down? Do you have to provide a mitigation for that? Is it the deletion or inaccessibility to your cloud account? Could it be the region of your cloud? And a region in public cloud is usually 2 or 3 distinct data centers that are within that 10 millisecond window where you can treat them as a cohesive, as a collective resource that an application can run on. And for cloud native applications, that's often the blast radius they have. You've also got the cloud, the inter-cloud abilities, and maybe you restore outside of that region to another geographic location. So maybe you go from the UK to America, maybe you go from Frankfurt down to Paris, and you need to consider how you would do that with the application constraints as well. And then centralizing distributed systems as well. So you might have calls for solutions that will accept an element of latency, but they will continue to work in providing this information where the application has this idea of eventual consistency or strong consistency. So if you want a fast answer, it will give you it. If you want the absolute right answer, it will give you that. But your application needs to be designed for that. And that's where you can open up things like globally distributed systems, which are resilient to any sort of issue around the world. But that really needs to be considered back right at the top. How do we make an application that can work in this way? So if you're looking at doing disaster recovery within a single cloud, that's very possible. Often you have services in public cloud which are providing something meaningful to you, say databases, things like that. And there will be applications that rely on that ability. If you have a requirement to make that work in your own data centers as well, then you've got a bit of a challenge because you'll have to re-engineer for your own data center. And the way that a lot of organizations get around this challenge is to somewhat commoditize the cloud and make applications portable. And the way that's being done predominantly is with something called containerization, putting your applications into these little boxes and then running them on an open source platform such as Kubernetes. And Kubernetes is something that manages those little things in boxes, those applications in boxes. Because that is an open source technology, you get away from some of the challenges where an organization could remove the right for you to have that. So we'll probably come back to Kubernetes a bit later. But for that portability and that standardizing how things work in cloud, we see a lot of Kubernetes coming into this, because you can do the same thing and they're all certified in AWS, Azure. You can do it on premises and it becomes very movable, which somewhat takes away the magic of public cloud, because these services that they've made that make your life really easy are not necessarily in scope, or they need to be thought about. But the trade-off of that is you can do the same thing everywhere. So if you're looking for multi-cloud or hybrid, where you do something on premise, you do something in public cloud, and you want a standardization over that, often we see that with a solution called Kubernetes.
Very interesting, and glad there is a solution with the uptake of cloud. We definitely need resilience there as well. But what about maybe this is the combination of the discussion. We started by promising that we would provide tips of how to test the resilience without breaking the resilience in systems. Um, could we do that? How can we do that? Should we do that? Is it mandatory? Can you share on that testing aspect?
Absolutely. So DORA says that we need to identify those risks and that they need to be severe but plausible. So it also gives you some expectation, as I said, about what risks we need to mitigate, but you've got to come up with your own, right, from your experience. So Article 25 of the RTS says, firstly, don't cause an outage from your testing, right? So it would be very easy to wade into a production environment and test it and cause some data corruption. That's not a scenario you want to be in. So I would say you want to build up to that, and we'll get on to how with that. You need to have scenario-based testing. So given this scenario, we would do this. And yes, severe but plausible, always in mind. We must test secondary site failover. So it's not enough to go from your primary site to your secondary site and say we're good. You've got to be able to fail back, otherwise you'll have an issue there. But that's fairly common. Where everyone who's been doing this for any meaningful amount of time will have a way to bring that back as well. Importantly, you need to test your third-party connectivity. So if your application moves from your primary site to your secondary site, or you've got a DR scenario where you've restored to public cloud because your on-premise has failed, you need to have the ability to test that your third parties can reroute that information, those requests over to you as well. And always remember that in terms of DORA, we're looking at critical and important workloads. So we're not necessarily looking at things that are very important to human resources, even though it's very important to the business. These are things that are going to materially affect the market and your ability to perform those executions that you have signed up with SLAs to the market for.
So now we know how to test resilience, disaster recovery testing, but how can we avoid testing disaster in the process?
So there's an element of chaos engineering. I think I mentioned it earlier on. This is where people get their thinking hats on and actively try and break solutions. Now, you don't do this in air traffic control, right? Not on the live system. Netflix, I believe, do it. They famously did it on their live systems, but if people can't watch a TV program, it's not the same as a market going down. So there are ways you can make this easier to test, and one of those ways go back to containerization and portability of applications and Kubernetes. So that ability to copy something, to create a lifelike mirror of what's there and run your tests on that like for like environment that is flexible, that can be created and destroyed for testing, means that when you get to testing a real system, which you should be doing if the scenario you has allows for that, you want to be doing the best testing you can given the constraints of the system, then you would be able to do that on a solution that is a clone of a production environment, and you can then build that confidence before moving over. You've got to make sure that also you can recover from if that testing goes wrong. So you still need some sort of remedy that says, okay, if we move this and it doesn't work, how are we going to get back to a known good state? And those restore point objectives, those restore time objectives need to be put in place as well. So there's the moving, and then there's that ultimate fallback of a remedy that says, here's how we get back to a good state, even if the regulation doesn't like that is what has to happen. You still need to go back, and historically in technology, maybe they're hourly backups, right? And you have everything as it was an hour ago. You want to get this as best you can, but with the constraints of the application.
And if we look down the lane, so we again look in our disaster, we have a scenario that we created, we tested it, and hopefully we avoided the disaster. But how could we prepare for an exit scenario? Typically, you would have maybe very critical suppliers to you that, of course, you rely, could be the cloud, could be other, even infrastructure, that you rely on specific service. It is not necessarily the most likely scenario, but it's still possible, and one that we have to prepare, that the supplier, the product, the service disappears. How can we prepare for that without having to to have a duplicate arrangement for everything?
So this is a challenge, and I think, and DORA talks about open source software as being an important piece, and I do really think open source is an excellent piece of the puzzle, because it means that you have access to that source code. So no one can take that away from you. You don't have to sign up to have access to it. So you could run that yourself. I have seen in closed source software a requirement from the organizations who are buying this stuff to have access to that software if there is a problem. Let's say the provider was no longer around, then they have the right to continue to use that software. So that's a legal remedy for that. But will they necessarily have the ability to operate that? I think what we've come to here, and this is a new piece of scope, really, compared to what the industry is used to, and this will continue to evolve. So up until DORA was brought in, the requirement to be able to do site-to-site failure of infrastructure might have been a plan based rather than an activity based, where you actually have to do it. And I think for exit scenarios, we're sort of in that scenario here, and we've got to think about this long term as to how we mitigate this risk. And again, the ability to use portable applications in containers probably helps with this, because then you can run it yourself. Also, those services where organizations run them for you are going to be harder to justify, especially for big organizations, banks, and so on. I think there'll be a further, and there was already a further requirement that everything is able to run inside their house, on their systems, so that there's no ability for anyone else to pull the plug. But these systems, as we've seen, in the recent outages, don't operate in vacuums, right? There's dependencies outside of that. So it is a significant challenge, but fortunately, the requirement at the moment is to have a plan and to make some inroads into solving that plan. But you're not expected to make changes that destroy your business, right? DORA is reasonable in that sense. So you need to have a think about it and an idea of the strategy, rather than going off and making a whole other platform that uses a whole other source of providers to solve the same problem. Because we're not flying airplanes necessarily, and that sort of governance isn't necessarily required. But there will be systems where that is absolutely required, and we need to look at the regulation in those terms as well. So it's difficult. When I look at solving these sort of problems, it comes down to what you want to do and what is an acceptable solution. So this goes back to that architecture decision record that when you select new things now, you put down a record for. And that is, again, right, given I have this problem, when this happens, then this must be completed. And then you have the acceptance criteria that you put in place when you selected the solution you have. And that will allow you then to go off and say, well, these other companies, these are the solutions, maybe they're open source, maybe they're closed source, will be able to solve that need. And you could start doing some proof of concepting on that. It's probably helpful as well that you have the ability to say, I have the ability to go here with this. Perhaps that will help you in your commercials as you come to negotiating, especially this closed source products as well, to give you a bit more leverage to get a better deal. So there's a bit of an upside there as well. I would say finally that some very specific solutions, such as services from cloud providers. So in AWS, there's something called Lambda. Lambda is an event-driven architecture. If you wanted to use, say, Azure's function-driven, event-driven architecture, then you're going to have to rewrite the whole thing. So this, again, leads to people pointing at, oh, maybe we should run this in containers, maybe it becomes portable, maybe we avoid this whole issue. And I think that will lead to people running things more in-house and people running more open source. And open source is a good thing. What do you think?
I like what you say. The exit scenario, but also the disaster recovery testing is literally giving companies options. They have options to select which way to go in a potential scenario that's most beneficial for them, but they also have options that they can show that they're prepared to their clients and regulators. So in a way, the trigger of the discussion is very much regulation, Digital Operation Resilience Act, but the benefit is for companies, for partners, and for users. So thank you very much, Anthony, for sharing your knowledge of how to create this benefit and how to test it. Let's hope we have more resilient and less disasters to actually learn from. But thank you already for sharing your knowledge, and I invite our audience to look at the other interviews of different elements covered in regulation, including DORA.
It's been a pleasure. Thank you, Eva. Thank you all for listening. And I love your channel. It's a wealth of information. So delighted to be part of it.